Good morning, students. Good morning to all of you. Today's topic is properties of charges. Okay, what is properties of charge? Okay, first of all, you have to see what is charge. Then I will see what is the property of charge. Okay, charge. A charge is a characteristics of any material due to which two body or two object attract each other or two object repel each other. Okay, it is a characteristics. Okay, it is a characteristics of any material due to which two bodies strongly attract or repel each other. Okay, strongly attract or repel each other. It is a characteristics. There are two types of charge. Two types of charge. First one is positive charge, and the second one is negative charge. Okay, I think up to which it is clear. Again, the charge, the SI unit of charge, SI unit of charge, that is coulomb. Okay, the SI unit of charge is coulomb, denoted by C. Okay, denoted by capital C. Okay, the SI unit of charge is coulomb, and it is a scalar quantity. It is a scalar quantity. It is a scalar quantity. So it can added or subtracted by algebraically. Okay, it is a scalar quantity. Two types of charges and same nature charge. Same nature charge repel each other. Okay, same nature charge repel each other. Same nature charge repel each other means what? Suppose there is a charge of positive charge and here a positive charge. This positive charge will repel this charge in outside. Okay, this positive charge apply a force to repel outside, and this positive charge also repel by means of applying some forces. Okay, same nature charge means negative also, and there is a negative charge and there is also a negative charge. This negative charge applies some force to repel this negative charge, and this negative charge will apply some force to repel this negative charge. Okay, in the same way, opposite nature charge. Okay, opposite nature charge attract each other. Okay, attract each other means what? Suppose there is a positive charge and here a negative charge. This positive charge will attract this charge towards, and this negative charge also attract this charge by applying some forces. So two opposite charges are attract each other, and same charge will repel each other. Okay, it is a scalar quantity. The charge is a scalar quantity. That's why it can added or subtracted by algebraically. It can added or subtracted algebraically. What is algebraically means? Suppose there is a charge of plus 2 coulomb, and you have to add this one Q1 charge and another charge of plus 3 coulomb, this one Q2 charge, and you have to add these two charges. Then it can be added as algebra. If you want to find the Q net means Q1 plus Q2, it becomes plus 2 coulomb charge, and 3 coulomb charge becomes plus 5 coulomb charge. Another example of a scalar quantity of charges, that is here you see, if you suppose there is a minus 5 coulomb charge, and you have to add this charge by plus 9 coulomb charge, this one Q1 and this one Q2, then you have to find the net charge Q net, then it will becomes Q1 plus Q2. Q1, that is minus 5 coulomb charge, and plus 9 coulomb charge, it will becomes plus 4 coulomb charge. I think up to which it is clear. Again, suppose there is another example. Suppose there is a charge of minus 4 coulomb charge, and you have to add this charge from minus 3 coulomb charge, that on Q2, then Q net becomes Q1 plus Q2 minus 4 coulomb plus minus 3 coulomb. Okay, it will becomes minus 7 coulomb charge, the Q net. I think it is clear up to it. Okay. Another properties of charges is charges are quantized, or charges are conserved. Okay. The next properties of the charge is the net charge of the system is conserved. Okay. The net charge of the system is conserved. What is the meaning of that? The net charge of a system is conserved. Suppose you rub by a glass rod, to a silk cloth. This one glass rod, and this one silk cloth. After rubbing, you find that the glass rod acquires positive charge. Whereas the silk cloth acquires a negative charge. How it is possible? Because the glass rod loses some electrons and the silk cloth gaining some electrons after rubbing. That's why after losing the electrons, the glass rod becomes positive charge, whereas the silk cloth becomes negative charge by gaining of electrons. You see here, suppose before rubbing, the net charge of the whole system is 0. Because it having a number of electrons and a number of protons in the same number. Suppose before rubbing, I am discussing here before rubbing. Okay, before rubbing. At initial stage, before rubbing, for glass rod, what happened with glass rod? Suppose there is a number of electrons on the glass rod. Suppose 10. Okay, I assume the number of electrons on the glass rod, that is 10. Then the net charge, or then the electrons having negative charge. So the charge on a glass rod in electron minus 10, and the number of protons on the glass rod also in same number but of positive nature. So the net charge of glass rod will become 0, plus 10 and minus 10 becomes 0. This one at before rubbing. And before rubbing, if you are asking about the silk cloth, then the silk cloth, suppose the number of electrons equal to 20. I assuming that 20, so minus 20, the electrons having a negative charge, and the protons in same number but of positive nature. So the number of proton plus 20. The net charge of silk cloth, what happens to the net charge of the silk cloth? It also becomes 0. So we can say the net charge of the system is equal to 0. The net charge is 0 plus 0, that is 0. Again, after rubbing, what happens after rubbing? After rubbing, what happens with the silk cloth and the glass rod? Suppose the 5 electrons the glass rod loses, means 5 electrons transfer from the glass rod to the silk cloth. Then what will happen? Here you see, if 5 electron transfer, suppose you can assume 5 electron transfer from glass rod to silk cloth. Then what happens? Here after rubbing, what happens with glass rod? You see here glass rod. How much electrons remaining after transferring 5 electrons from the glass rod? Here minus 10 electrons is available on the glass rod at the initial stage. After rubbing, it becomes minus 5 because 5 electrons transfer. But the proton number is same, that is 10. The net charge of the system, net charge of the glass rod equal to plus 5. And you can see here after rubbing silk cloth, what will happen with silk cloth, it gaining the electrons, that is 5 electrons extra on the silk cloth, the number of electrons becomes minus 25 because 20 is available already. Then proton is 20, there is no any disturbance on the proton. The net charge of the silk cloth, that is 20 minus 25 becomes minus 5. You see here what happens with the glass rod, it loses 5 electrons, that's why the net charge of the glass rod becomes positive, whereas the net charge of the silk cloth becomes negative. Then you can write, or you can remember that after losing anything, after losing electrons, anything becomes positive charge, or after gaining electrons, it becomes a negative charge. Then here you see the net charge of system, the net charge of systems becomes plus 5 and minus 5, again it becomes 0 because this one net charge after rubbing 0 and this one net charge before rubbing 0 plus 0 also 0. So we can say the net charge of the system is conserved. There is no changing, or there is no any creating of electrons. New electrons you cannot create, or new charge you cannot create. Okay, I think up to which you are able to follow me. Again, the next property of charge is charges are quantized. Okay, you see the next property of charge is charges are quantized. Charges are quantized means charge is an integral multiple of E. What is the meaning of integral multiple of E? You see here the next property is, that is charges is quantized. What is the meaning of quantization of charge? That is charges are you can write here, charges are integral multiple of E. Integral multiple of E, you can write here Q, that is equal to NE, where N equal to any integer. N is equal to any integer. So we can say here Q is integral multiple of E, and E is the charge present on one electron, that is 1.6 into 10 to the power minus 19 coulomb. Okay, the charge which is the magnitude of charge which is present on one electron. Okay, so you can suppose the number of electrons transferring from the glass rod to the silk rod, the 5 electron transfer, then how much electrons, how much charge gained by the silk rod? The charge, you can write here, charge gained by silk cloth. How much charge is gained by the silk cloth? You can write 5 into E. 5 into E because 5 electrons transferred on the silk cloth. 5 into the charge on electron is minus 5, so you can write a minus 5 because charge gained by the silk cloth, that is it gains, so its charge is minus, so you can write a minus electrons, how much the value of E, that is 1.6 into 10 to the power minus 19, it becomes 8.0, that is minus 8 into 10 to the power minus 19 coulomb charge. Okay, I think up to which you are able to follow me. Again, you can write the charge loosed by glass rod, or the charge present on, after rubbing, the charge present on silk cloth. You can write here the charge present on silk cloth, charge present on silk cloth after rubbing, and the charge present on glass rod. After rubbing, the charge present on glass silk cloth, that is minus 5e, because the charge gained by the silk cloth, but the glass rod loosed. So it having a positive charge, that is 5e plus 5 into 10 to the that is the value of E 1.6 into 10 to the power minus 19 coulomb charge. It's also become 8.0 into 10 to the power minus 19, that is in positive in nature. You see, the value is same but of positive nature. This is, you can see here, you can see here the value, that is n, that is n is any integer means you can write 0, 1, minus 2, 3, 4, 2, whatever it is, but it values integers, not in fraction, not in decimal. So if anybody asks to you that the charge, that is there is a charge, its value is 1.65 or you know that the charge present on 1 electrons here, the charge present on 1 electron, that is 1.6 into 10 to the power minus 19 coulomb charge in negative nature, because it having a electron charge, so it is negative in nature. If anybody asks to you that there is a charge, its value is 3.0 into 10 to the power minus 19, it is possible? No, it is not possible, because the value may be the value is 1.6 into 10 to the power minus 19. Again the next value of the charge is this one, 1 into 1.6, the next value is 2 into 1.6, 10 to the power minus 19, it becomes 3.2 into 10 to the power minus 19. Again the third value of the charge is 4.8 or 3 into 1.6 into 10 to the power minus 19, that is 4.8 into 10 to the power minus 19 coulomb charge. I think you are able to follow me here. So if anybody asks to you that a body having a charge of 4.0 into 10 to the power minus 19 coulomb charge, it is possible. So you can write it is not possible. This one possible, this one possible, this one also possible, but this is not possible. Suppose anybody asks you 4.3 into 10 to the power minus 19 coulomb charge, it is possible? Not, it is not possible. The next value of the charge is 6.4. The next value, that is 6.4. You can add 4 into 1.6 into 10 to the power minus 19, that is 6.4 into 10 to the power minus 19 coulomb charge. Here you see, this is possible because this is the integral multiple of E. This is one also the integral multiple of E. So it is possible, but the 4 into 10 to the minus 19, it is not integral multiple of E. It is not a integral multiple of E. So this is not possible, and this is also not possible. So you can see here that this is the whole property of charges. I think you are able to follow me up to which. Thank you very much.